Hello, I am Jouni Tuominen from the Helsinki Center for Digital Humanities HELDIC, University of Helsinki and Aalto University. In this presentation, I will talk about linked open data infrastructure for digital humanities. First, I will briefly introduce you the concept of linked data and why it's useful in a digital humanities context. Then, I will talk about our work on linked data infrastructure for digital humanities. In digital humanities, which can be seen as a branch of humanities that applies computational methods, data is of great importance. For example, when we think about cultural heritage contents, such as artifacts in museums, literature, music, arts, biographies, and cultural sites, we realize that the individual collections are related to each other in many ways. For example, a painting can depict an event in the Finnish epic Kalevala, and the same event can have inspired a musical piece. We can have a biography of the painter, and the painter lived during his lifetime at a cultural site for which we have encyclopedic information, and which can be put on a map. These connections are usually implicit, natural for humans, but are not encoded in the data for the computer to understand. Similarly, the different memory organizations use their own IT systems, data models, and formats for managing and publishing the data. In many cases, standards are used for some parts of the data. For example, coordinate systems are used to harmonize spatial data. However, it is not easy to aggregate data from different systems and use them for digital humanities research for solving complex questions. Linked data is a paradigm and a set of technologies for publishing data in a harmonized way. The idea is to use shared data format, models, and vocabularies for publishing the contents. The 5-star linked data model gives a basic idea on how this is done in practice when publishing a dataset. The first star is given if the data is made public using an open license, such as a Creative Commons one, in any format, for example, as a PDF file. The second star is awarded if the data follows a structured format. For example, if the data is organized as an Excel spreadsheet using columns to distinguish the different attributes of the data. For the third star, the data has to be published in an open format, for example, in a CSV file. After the third star, we are moving more heavily to the linked data world. To get the fourth star, the data has to have globally unique identifiers for individual objects, let's say people and places that are described in the data. The fifth star, the final level in this model, is given when the data has links to other datasets to provide contexts. Once the data is published as linked data, the contents get connected and enriched with each other and can be utilized using shared tools. The resulting linked data cloud can be seen as a giant database which can be queried using a standard query language, SparkQL. To realize this vision for publishing and using linked data in digital humanities research, infrastructure and support services are needed. Firstly, metadata models and ontologies are needed for harmonizing the data. Secondly, we need tools for creating and processing data. We need ontology services for accessing and utilizing the ontologies for content production and, for example, for ontology-based information retrieval. For creating linked data out of textual data contents, we need Linguistic and other tools. Also, services for publishing the data for researchers and other organizations are needed. Finally, researchers need analysis and visualization tools for using the data in their research. Metadata models define the structure of the data. For example, SciDoc CRM is an event-based model for harmonizing and linking cultural heritage contents. In its core, we have the class event or activity here, which can be used, for example, for representing the event Crimea Conference, which was held during World War II, where the heads of government of USA, UK and Soviet Union discussed the post-war reorganization of Europe. We can use SciDoc model to state that the conference took place at Yalta. It happened at some time within February 1945, and Winston Churchill, Franklin D. Roosevelt and Joseph Stalin participated in it. Note that when we refer to people and places here, we use their identifiers, which also function as web addresses. We can also attach information about the photograph and a document, Yalta Agreement, that was created during this conference. This generic model is applicable to many kinds of cultural heritage data, as events can be used, for example, for representing birth, death, artistic creations, or battles of war. To populate the metadata model with references to people, places, events, times and periods, and keyword concepts, we need domain ontologies. Ontologies model the domain in question by providing definitions of the entities, giving them unique identifiers, and provide machine-readable semantics for them. By using ontologies, the references to entities are harmonized. For example, instead of using one of the many possible transliterations of Pyotr Tchaikovsky, we use his identifier, in this example minted in DBpedia, which is a representation of the data inside Wikipedia. Ontology services provide user interfaces and application programming interfaces for searching and browsing ontologies. By utilizing them, manual and automatic content production processes can be built, for example, for generating machine-processable metadata for library catalogs. A research prototype called Ongi was developed in one of our projects, and it was later turned into a production-level ontology service, Finto, by our colleagues at the National Library of Finland. In 2019, Finto had 280,000 users, 1.9 million page loads, and 32 million requests in its application programming interface. For creating linked data based on text documents, we can utilize text mining methods. For processing natural language, linguistic tools are needed. For example, for texts in Finnish, a highly inflected language, lemmatization tool is needed in order to base form the different forms of a word. After that, we can utilize named entity recognition and linking tools to identify people, places, concepts, etc. in text and to link them to ontologies. We have combined a set of open source linguistic tools developed by ourselves and our colleagues at different universities into language analysis services to aid these processes. Once a linked dataset is ready to use, it can be published on a data publication service. For that, we have developed Linked Data Finland service, which extends the 5-star linked data model into a 7-star model. Here, we emphasize the documentation and validation of the data, both in technical terms and also for the future users in order to be able to trust the quality of the data. In order for researchers to be able to use the data, they need to understand how the data is structured, how it was collected, what are the limitations and biases, and so on. The datasets in Linked Data Finland can be downloaded as data dumps, or users can make queries to it using the standard and powerful SPARQL query language. We also provide simple browsing facilities for the data. For using linked data in research, analysis and visualization tools are needed. These include, for example, query builder tools, map-based visualizations, network analysis tools, and infographics. These interfaces can be built directly based on the data published in Linked Data Finland, on top of its open SPARQL endpoint. By combining different analysis and visualization methods, we have created the Sampo User Interface Framework, an open source framework for building semantic portals. The Sampo model has been used for building rich user interfaces based on faceted search and visualizations for different kinds of cultural heritage data. Thank you. For more information about our work on linked open data infrastructure for digital humanities in Finland, please see our webpage.